This video is a video to give some genetic linkage tips. I did one of these in the PowerPoint lecture over chapter 5, but this one I want to do another one, kind of give you my tips of how to solve these to hopefully make them a little bit more accessible as you complete your homework. So here's an example of a genetic linkage word problem. It says, in rabbits, chocolate colored fur is dominant to white fur, straight fur is dominant to curly fur, and long ears is dominant to short ears. The cross of a tri-hybrid rabbit with straight chocolate colored fur and long ears to a rabbit that has white curly fur and short ears produces the following results. And here we see those results, right? We have white short straight, 13, chocolate long straight, 165, chocolate long curly, 13, white long straight, 82, chocolate short straight, 436, chocolate short curly, 79, white short curly, 162, white long curly, 450, for a total number of 1,400 rabbits. The question then wants us to determine the order of the genes on the chromosome and identify the alleles that are present on each of the homologous chromosomes in the tri-hybrid parental rabbits. Then we need to calculate the recombination frequencies between each of the adjacent pairs of genes. Okay, a lot to unpack. Some of you may be feeling very overwhelmed by this. So where do we begin? First thing, let's identify the traits that are dominant and recessive, and let's write those out to make them simple. So I'm going to put dominant, recessive, okay, so for our first pair, we have chocolate is the dominant trait, and white is the recessive. And that's W. This is W wild type, so plus. Okay, for the second one, we have long ears is dominant to short. So long ears. Short ears, which is S. And then we have straight and curly fur. So straight is the wild type, so it's the plus, and curly is the mutant. It is C. So those are our traits. Next part. Identify the parental chromosomes and draw out the parental. It helps to draw out that parental chromosome. So our two parentals, it says we have tri-hybrid rabbits. One is straight, chocolate, and long-eared. The other is white, curly, with short ears. Now, because white, curly, and short, those are all recessive traits. We can see those right here, white, short, curly. That means in order for a rabbit to have that, they have to be homozygous recessive for all of those. So I know that one of the rabbits was this, white, short, curly, white, short, curly. Now you may ask, why, hey, Professor Smith, why are you writing them out this way? Why don't you put WWSSCC? I like to draw the chromosomes so that I can visualize the crossing over that would have to occur when I'm trying to find my recombinants. Okay, now for the other individual, this individual right here, there's two chromosomes. We can see that they are straight, chocolate, and long-eared. Those are all dominant traits. So the question is are they homozygous dominant or are they heterozygous for each of these traits? Because that would still result in a dominant phenotype. In order to answer this, we can look to our offspring and we find the offspring that have the largest number of individuals. Those offspring are going to be non-recombinants. They're going to have the parental genotype. And as you see, that's going to be these ones and these ones. 436, and 450. Now, if you don't remember this, you could end up doing this problem very wrong. So it's important to identify which ones are our largest. Now, because these offspring came about because of a cross of getting one chromosome from, let's say, the mother and one chromosome from the father, that then gives them their genotype, and from their genotype we can infer their phenotype. And since in this case, let's say this is the father can only produce one type of gamete. All of these individuals over here are going to have one chromosome that looks like this. So if I draw this out, one of those chromosomes is going to have the 3 recessives, WSC. So in order for this individual to be chocolate, again, chocolate is a dominant trait, they're going to be wild type here. They're going to have the dominant allele. I'm just going to put a plus. I could put W plus, but I'm just putting plus to save a little bit of space. In order to be short, now short, that was a recessive trait. So I have to have another recessive allele. I have to be homozygous there to be short. And then to have straight hair, that's a dominant trait. So again, I would be C plus. I'm just going to put a plus. Okay, so wild type, homozygous, wild type for the 3 alleles. Likewise, I would do this down here. Okay, in order to be white, that's a recessive trait, so I would have to have the recessive allele. Okay, in order to be long, that's a dominant trait, so I would be wild type here. And again, to be curly, that is a recessive trait, so I would have the recessive allele. Okay, so now, as you can see, I can see what the 2 alleles were of this individual if no recombination occurred. And I know no recombination occurred because these are the largest proportion of my offspring. So I can go ahead and come back up here and fill in what these were. One of the alleles had to be wild type, S wild type, and the other allele is this one, W wild type, curly. Those are my 2 alleles. Now, if I really want to, I could write in the W, I could write in the C, so that we know it's C, W plus, C plus, and that this would be S plus. But again, usually I just abbreviate it and just leave it as the plus. Okay, so I've already answered this part, each of the homologous chromosomes in the trihybrid rabbits. That's this right here. So that's done. What's my next step? Well, now I need to identify the offspring genotypes. Okay, and again, this helps to draw out the chromosome. We already did that for 2 of them, so I need to do it for the others. And remember, all of these are going to have this chromosome on the bottom. So you could draw all these out, or you could just remember what that our bottom is all recessives, and so in order to have these, I'm going to just draw the top chromosome. Okay, so you're going to just see the top chromosome because that's really the one that I'm going to be most worried about. So in order for me to be white, again, if I'm already recessive, then I have to have a recessive here. So I'm going to be W. Short, that's also a recessive trait, so I'm going to be S. And straight, that is a wild trait, so I'm going to be plus. Okay, that's that chromosome, WS plus. Okay, the other chromosome that it obviously has is the WSC. All of them would have that. Okay, so now I come here. Chocolate, that's a dominant trait, so I would be plus. So wild type. Long, that's also wild type. And straight, that's also wild type. Okay, go to the next one. Chocolate, wild type. Long, wild type. Curly, recessive. Next one, white. That is a recessive trait. Long, that is a dominant trait, so I'm wild type. Straight, wild type. Go to the next one, chocolate, wild type. short is recessive. Straight, wild type. Chocolate, wild type, short, recessive, curly, recessive, right? White, recessive, short, recessive, curly, recessive. White, recessive, long, dominant, curly, recessive. Okay, I have all of my offspring. Okay, and I have them written out so that I can kind of view it. So my next step is I need to calculate the percent recombinance for each gene pair. So let's pick, it doesn't matter which one I start with, I'm going to just pick one. Let's say I'm going to start with white and short. This gene pair. So what I'm going to do now is I'm going to come over, I'm going to look at these and I'm going to see, did a recombination occur in order for me to get this? A recombination on which chromosome? This chromosome. So I am WS. Are WS on the same chromosome? No. Here's the W, there's the S. In order for me to be that, there had to be a crossover event. There had to be recombination. So I'm going to write, these are recombinants for WS. So I'm going to write 13 here. 13. Go to the next one. Plus, plus. Do I have wild type in the same? No. Again, recombination, so I'm going to type that number in, 165. Go to the next one. Plus, plus. No, we just did that there. Again, it's a recombinant, so 13. Next one, W plus. Oh, W plus, that's on the same. So that's not a recombination. That would be considered like a parental there. Next one, we already identified these as parental, so it certainly shouldn't be recombinant, but plus S, and again, there's our plus S. Right here, plus S, not a recombinant. WS, WS on different chromosomes is a recombinant. I'm going to add in that number of 162. And then my very last one, W plus, I already identified as parental. W plus, it was a parental. So now I add these up. $13, carry the 1. 7, 8, 9, 15 plus 1, so 353. 353. I will take that and I'm going to divide it by 1400. Right? So 353 divided by 1400 is going to give me my percent recombinants. So that comes out to be 0.252, okay, times 100 equals 25.2 map units. Okay? Let's go on to the next gene pair. Now we'll do short and curly. So I'm going to do this all over again. I'm going to come over here. I'm going to look at the first one. Okay, now I don't care what's in this first position. I'm only looking at these two genes, short and curly. So S plus, not a recombinant. Plus plus, those are on difference. So I'm going to write that in. Those are recombinants. 165. Plus C on the same one, not a recombinant. Plus plus on different chromosomes, had to be a recombinant, had to have a crossover event to create it. So I'm going to write that in. S plus S plus on the same, not a recombinant. SC, SC, they're on different. That is a recombination due to crossover, so I will write those numbers in. 79. SC, SC was recombination. Add that in, 162. Last one, plus C, 4. It's not a recombination, so I don't write it in. So 165 plus 82 plus 79 plus 162 is going to equal 488. Now, if I divide that again by 1400, I'm going to get 0.349. Okay, times 100 to get my percent. It's equal to 34.9. So 34.9. Now I come to my very last one. Make this one a little bit smaller down here. This is going to be between white and curly. Okay, white and curly. Now, I need to be careful when I do these ones that I'm looking at this position, so first position, and I'm looking at third position. I do not care what is in the middle. Do not get confused by that position. I'm just looking at those two. So here, I am W and I am wild type. W, wild, there had to be a crossover event to do that. I don't care that I'm S here, because you can see I went W, then I crossed over to ST. Okay, doesn't matter because I could have WS and then cross back to over. So we don't want to get confixed with just this middle one. I just want to look. W and T, did a crossover have to occur in order for that to happen? Yeah, so I'm going to write that number in. 13. Okay, wild type, wild type. Wild type, wild type. Okay, I'm not going to put that in. Next one, wild type C. Wild type C on different chromosomes. So I'm going to write that in, 13. Wild type plus. Wild type plus. And again, I'm looking at first position and third position. That occurred, so I'm going to write that in, 82. I don't even need to do this one because I already know it's parental. I already identified it as parental, so I'm going to skip it, come here to wild type C. Wild type C, first position, third position are on different chromosomes, so I'm going to write that one in, 79. WC, WC on the same chromosome in first and third, so that one doesn't. So I'm not going to do that. Last one is a parental, so I don't need to even worry about that one. Add these up, and what do I get? Take 13 plus 13 plus 82 plus 79. Gives me a grand total of 187. Again, divide by 1400. That's the total number of offspring. That gives me my percent recombination for these two genes, which is 0.134 times 100 gives me 13.4 map units. Okay, I've solved this part right here. All right, I've already solved that because I have that. This, and this. So the only thing I have left to do is to determine the order of the genes. There's ways you could do that just by kind of looking at this, but now that I've solved for these frequencies, I can figure that out all on my own. So now I just draw the chromosomal order, and I want to pair. The pair with the largest map distance are going to be my two ends. So in this case, my 34.9 is going to be my largest map unit. So S and C should be on my two ends. So if I draw out what the chromosome would look like, let's just draw it like this. I'm going to put S over here, C over here. This is 34.9 map units. Okay, and then I can take my smallest one. So my smallest is going to be the 13.4. That's WC. So that means W is going to be closer to C than to S. So I will draw that in, put it right about here. Say here's my W. So this is 13.4 map units. And then between S and W, we have 25.2 map units. And I don't need to be concerned that my 25 plus my 13 isn't equaling 34.9. I don't need to be concerned about that because of interference that can occur. And this is how I solve it, right? So this is my order, SWC, or you could put CWS, doesn't matter, either way. And I found all my map units. Those are the steps. Honestly, these things aren't that difficult once you follow these steps and kind of just methodically think. It's really important that you know this cheat. If you find the two largest, right, you know those are your parentals. From that point on, you're not gonna go wrong, okay? You can work through and calculate this out. Something you may have noticed while I was doing this, you'll see that these are kind of exist in pairs, right? So I have these two kind of big numbers, they're kind of close together. I have these two small numbers, they're kind of close together. I have these other two numbers that are around the same number of recombinants. These are the ones that kind of pair up with each other. This is the one chromosome recombinant, this is the other chromosome's recombinant. And so we should have these in pairs. So when you're doing this, if you get something that looks really off, like first of all, these should always be like even numbers. If you have an odd number in here, you did something wrong. And if they don't look like they kind of pair, you have two pairs, or sometimes it might just be one pair, depending on the type of problem. But if it isn't a paired grouping, that might be something that you need to look at. Maybe you got this initially wrong, right? Or you counted your recombinants wrong. So go back and check on that. That's how you solve a genetic linkage problem.